Hey there. In this video, we are going to learn how to solve a linear first-order differential equation using an integrating factor. Now, once you've decided that that is the type of differential equation you're dealing with, and this is the method we want to use, the first thing we want to do is get the differential equation into standard form. Now, standard form means that the derivative is not being multiplied by anything. So here it would be dy dt plus p of the independent variable, so that's going to be t here because that's in the denominator of the derivative, times y equals some function of t. So I have the first derivative plus a function of t times y equals a function of t. And so if once I get into that form, then I can go about finding my integrating factor. Now, looking at the differential equation we have here, we have 2 times dy dt minus y equals 4 sine of 3t. Now, it's almost in that standard form. The only issue we have is there is a 2 multiplying by the derivative. So if I can get rid of that, then it'll be in standard form and I can identify p of t. So to do that, I'm going to divide everything in the equation by 2. And I get dy dt minus 1/2 times y equals, and 4 divided by 2 would give me 2 sine of 3t. And now it's in standard form. And I can look at what is multiplying by the y on the left side of the equation, and that is going to be my p of t. So here that's negative 1/2. So p of t equals negative 1/2. And to find the integrating factor, which we often call mu, I'm going to integrate this. So the integral of p of t with respect to t is going to be the integral of negative 1/2 dt. Now integrating that, we get negative 1/2 t. We're not going to bother with constant integration. This is kind of a trick that we're using. And so you don't need a constant integration that only would mess things up. We are just looking for the antiderivative here, the simplest version of it that would work for this method. So the simplest version, the simplest antiderivative of negative 1/2 is negative 1/2 t. And so to get the integrating factor here is going to be mu, which is a function of t. I'm going to take e to the integral of p of t. So mu is going to be e to the negative 1/2 t, or I'm going to write it as negative t over 2. Just make it a little easier to see what's going on in that exponent. Okay, so there's my integrating factor. I'm going to multiply the differential equation in standard form by this integrating factor. So every term throughout gets multiplied by mu. And I end up with e to the negative, oh, let me switch colors here. Go back to the black. So I have e to the negative t over 2 dy dt minus 1/2 e to the negative t over 2 times y equals 2 e to the negative t over 2 times the sine of 3t. Now on the left side of the equation, it can be kind of hard to see, but this is actually product rule. If I were to take the integrating factor, negative e to the t over 2 times y, and take the derivative with respect to t, I would get what we have on the left side of our equation right now. If you look, I have e to the negative t over 2 times the derivative of y plus the derivative of e to the negative t over 2, which is negative 1/2 e to the negative t over 2 times y. So that's exactly what I would get from multiplying using the product rule here with these two variables. And so I'm going to go ahead and reverse that product rule. I'm going to rewrite this left side as the derivative of that product of the integrating factor and y. And it should work out this way every time if we've calculated our integrating factor correctly. It's always good to check that the coefficients we have here on the dy dt and the y are actually derivatives. One is a derivative of the other. But as long as they are, then you know that you've done things correctly. And so now that derivative of e to the negative t over 2 times y is equal to 2e to the negative t over 2 times sine of 3t. And so now that I've got a derivative on the left side, to get rid of it, I can integrate. So I'm going to integrate both sides of this equation. And we can just go ahead and throw an integral out in front here, as long as we're clear that we're integrating with respect to t. And so on the left side, the integral and the derivative just effectively cancel out. And I end up with just e to the negative t over 2 times y. And then I just need to integrate that right side of the equation. Now, this is one that you can integrate using integration by parts a couple of times, but usually once you've gotten past that section in Calculus 2, we usually just go to the formula for this one. So I'm going to use the formula to integrate this. And so that's going to give me 8 over 37 e to the negative t over 2 times, in parentheses, negative 1/2 sine of 3t minus 3 cosine of 3t. And then don't forget that constant of integration at the end. All right, so I've integrated that left side using a formula from a table of integrals. And the only thing left to do here is to solve for y. And I'm going to do that by dividing by e to the negative t over 2. So if I divide that out, it will cancel in this whole first large term with the parentheses. And that's a typo there. That should be 37. There we go. So I end up with 8 over 37 with the t gone times the quantity, negative 1/2 sine of 3t minus 3 cosine of 3t. Now, this is the easy part to miss. I also need to divide the constant of integration by this e to the negative 2 over t. So this becomes c e to the positive t over 2. So I'm dividing by a negative exponent, so that just moves it to the numerator to become positive. And I can clean this up a little bit by distributing out the 8 over 37 to get a final answer. So we end up with negative 4 over 37 times sine of 3t minus 24 over 37 times cosine of 3t plus c e to the t over 2. And there's our answer.